Today, we'll be talking about possibly NASA's most controversial creation, the James Webb Telescope. After years of being under development, the telescope was finally launched in December 2021. What's the controversial past attached to this creation? And why is it considered to be revolutionary? Stick around to find out more. The James Webb Telescope is a space telescope created by NASA with assistance from the European Space Agency and the Canadian Space Agency. It is expected to be NASA's flagship project in astrophysics, succeeding the Hubble Space Telescope. The Hubble Space Telescope, named for its scientist Edwin Hubble, was launched in 1990 and represented a significant step forward for astronomy. Astronomers on Earth seek distant mountaintops and deserts to install large telescopes in order to see a dark sky free of pollution and dazzling lights. However, the slight haze and luminosity of Earth's atmosphere still obscure their vision. Astronomers will be able to view so far back using this telescope that they might be able to identify and detect stars and galaxies from millions of years ago. The Webb is named after the man who commanded NASA in the decade preceding up to the moon landing, James Webb. The technological accomplishment of NASA's newest telescope is undeniable. It has the potential to build on Hubble's achievements. In two essential aspects, Webb outperforms Hubble. The first is simply its size. Hubble was around the size of a bus, while Webb is more akin to a tennis court in size. The largest telescope NASA has ever attempted to launch into orbit is Webb. But it's not just about the overall size of the apparatus. When it comes to reflective telescopes, the size of the curved mirror is crucial. The mirror on Hubble's spacecraft measured 7.8 feet in diameter. Webb's stunning gold-hued mirrors have a combined diameter of 21.3 feet. That's over 6 times the quantity of light collecting space. Astronomers will be able to view so far back with Webb that they may be able to identify the first stars and galaxies. Light from the Big Bang, which took 13.3 billion years to reach us, has been spotted by Hubble dating back 400 million years. Another feature of the Webb is the kind of light it catches. There are many distinct types of light, although the human eye can only detect a small spectrum of light known as visible light. The cosmos includes a vast amount of light outside of this range, including ones with greater frequency, higher energy forms such as ultraviolet and gamma rays. Sounds spectacular, right? Well, it should be stunning, considering the fact that it has a value of a whopping $10 billion, which is actually 10 times more than what was estimated while planning. Multiple blunders by NASA during its creation delayed the launches and increased the cost by billions, making the telescope one controversial mark on the face of NASA. Scientists were eager to get started, but the Webb revolution took longer than expected. Contractor issues, wrong cleaning chemicals, and loose screws were some of the causes of all the launch delays. The intricacy of the Webb, according to NASA's Amber Strong, is a significant cause of all of them. The fact that Webb will be nearly 1 million miles distant, 4 times the distance between the Earth and the Moon, raises the stakes. Hubble was launched to a height of roughly 340 miles above the surface of the Earth. For a good reason, it would be far away. Webb must be kept cool, since it is an infrared telescope. The Earth is heated and emits infrared light. The Webb will revolve around a location known as the Lagrange point. There is a region of space in which the telescope can stay cool while also trying to stay in alignment with the Earth as they orbit the Sun. Surprisingly, any scientist around the globe could request to use the Webb Space Telescope as long as they submit a peer-reviewed research plan. It's a tough nut to crack, however. NASA launched the James Webb Telescope from French Guiana on Christmas Eve, December 24, 2021. The ceremony was broadcast live on a NASA ESA joint webcast with a countdown in French. The 14,000-pound sensor was launched from the top stage of the French-built rocket approximately 865 miles above the Earth after a 27-minute hypersonic flight into space, and gradually extended to a tennis court size over the following 13 days as it floated on its own. The Webb drifted smoothly away after it was launched, seen on live video by a camera attached to the rocket's upper stage, eliciting screams and clapping from ecstatic flight engineers in the Mission Control Center. As Webb's solar energy array was deployed, Flight controllers certified that the power source was operational. The Webb telescope is now on its route to a location roughly 1,000,000 kilometers from the Earth. The telescope must accomplish a challenging mechanical maneuver called self-assembly while on its course. Because the telescope is just so giant, it had to be launched inside a rocket folded up. It must be unfolded in its different components, from its mirrors to its sunshield, over the course of several weeks. The telescope was initially expected to be active for 5 to 10 years, but NASA's recent research indicated that the telescope will possibly be able to sustain scientific activities for considerably longer. The excess fuel is due to the accuracy of the Ariane 5 rocket on which the telescope was sent into space, according to NASA. It's also because the first and second mid-course corrective procedures were executed with such accuracy. The accuracy of these adjustments, according to NASA, leaves the spacecraft with more fuel to retain its ultimate position for studying the cosmos. However, the space agency warns that several circumstances might limit JWST's longevity in the end. According to NASA, the Hubble telescope was supposed to last 15 years, yet it's still going strong after more than 30. However, there is one significant difference between the two, and that is that the Hubble can be repaired by astronauts, but the JWST cannot. JWST was also able to deploy its solar array earlier due to the precision of the launch trajectory. The deployment of JWST's solar array was scheduled to commence roughly 33 minutes after separation from the Ariane 5 rocket. According to NASA's news statement, it happened approximately 29 minutes after launch because JWST was in the proper position after separation. However, unlike solar array deployment, which was automated, subsequent deployment will be guided by humans. If anything goes wrong, or unlike the plan suggests, during the deployment of the sunshield, it may spell the end for a telescope that has been in the works for decades and has already been criticized for growing prices and protracted delays. Hold up, viewers, before we tell you more about the launch, make sure you hit the thumbs up button so that this video reaches more people and subscribe to Space Facts. Okay, let's move on. As of now, a team behind the James Webb Space Telescope has completed the deployment of the spacecraft's 70-foot sunshield, a critical step in getting it ready for science operations. Prior to launch, the sunshield, which was roughly the size of a tennis court when fully expanded, was compressed to fit within the load area of the Ariane 5 rocket's nose cone. 3 days after launch, on December 28, 2021, the Webb crew began remotely installing the sunshield. On January 4, 2022, NASA conducted a teleconference to announce the completion of this crucial stage. The 5-layered sunshield will shield the telescope from the sun's, Earth's, and moon's light and heat. The sunshield was unfolded and tensioned using 139 of Webb's 178 release devices, 70 hinge assemblies, 8 deployment motors, 400 pulleys, and 90 separate cables totaling almost a quarter mile in length. The crew also took a day off from deployment operations to optimize Webb's power sources and tensioning motors, ensuring that Webb was in top shape before starting the critical process of sunshield tensioning.